All right, guys, this is lesson 99, talking about inverse variation. So before we get into inverse variation, we got to review a little bit about direct variation. All right, so we should know a couple characteristics of direct variation. We should know that the constant in direct variation relationship is always equal to the y value divided by the x value. We can also follow the form of y equals k times x, or y equals some constant times x. We also know that as one variable increases, the other does as well. And graphs are linear and pass through the origin, right? So from lesson 98, we had a direct variation graph for the number of tickets and their cost, right? From that example. So as I bought 0 tickets, it cost $0, 1 ticket 5, 2, 10, 3, 15, so on and so forth. So, right, we have a constant of 5. The tickets each cost $5. It passes through the origin, it's linear. As one variable increases, the number of tickets goes up, the price goes up. And we can find our constant by dividing the output by the input. So there's a little review. So inverse variation now is going to, surprisingly, have inverse of some of these, okay? So let's take a look at some of the characteristics of inverse variation and then do a couple examples, all right? So our first, right, is that instead of k equaling y divided by x, we're gonna have x times y equals k. So in an inverse variation relationship, the two variables multiplied together always equal a constant, okay? Next, as one variable increases, the other decreases. So in direct contrast to over here, whereas one variable increases, the other does as well. Here, one variable goes up, the other one's going down. And then last, graphs are non-linear. Okay, so they do not go in a straight line. All right, so let's look at a couple examples. All right, so the first is baking a cake. All right, so first example, we are baking, we're not even baking. Let's just say we're having a birthday party, all right, and we have a cake at our birthday party. And we're trying to figure out how much of the cake each person gets, all right? And so here we go, right? At my birthday party, okay? I don't invite anybody, it's just me. So there is one person at my birthday party. So let's say that the input is the number of people and the output is how much cake they get. Okay, so if I have one person at my birthday party, just me, I get the entire cake, right? I get the entire cake. The whole cake is for me, right? And I say, yeah, that's kind of boring, right? I want to have two people, me and my best friend. So how much cake do we each get? We each get half of a cake, right? He gets a half, I get a half. Makes up the entire cake. I'm like, all right, just me and him, that's gonna be kind of awkward sitting there eating cake. So I say, I'm gonna invite myself and 3 other friends for 4 of us. Then we each get 1/4 of the cake. Pretty good, 1/4 of the cake. But I'm like, I don't know. That's only allowing for like 2-on-2 street hockey. Let's get a full group together, and we'll go me and 7 friends. So 8 of us. So if there's 8 of us, then we each get 1/8 of the cake. Okay. So let's see. Is this an inverse relationship? Right. Well, do I have a constant? Right. Do I have a constant? I do. The constant is the cake, right? And so I know that an inverse relationship takes my input and my output, and then if I multiply them together, I always get the same thing. So x times y here is going to be 1 times 1, which is 1. 2 times 1/2 is 2 over 2, which is 1. 4 times 1/4 is 4 over 4, which is 1. And 8 times 1/8 equals 8 over 8, which is 1. Okay, so I have my constant of 1. And I know, right, as one variable increases, the number of people I invite, the bigger my party gets, the less cake everyone gets. Okay, so this is an example of a inverse relationship. All right, let's do another. Okay, so I'm gonna have you guys fill this in. I'll set it up for you. All right, so I'm trying to travel. I'm driving somewhere. I'm trying to travel 240 miles. So I'm driving to the beach, and I know that it's 240 miles from where I am. I want to know how long will it take me to get there driving at different speeds. All right, so let's say that the x value is your speed and the y value is your time. All right, we'll make a little table. I'm getting better at this. Okay, there we go. Split it up. All right, so if I drive 80 miles per hour, what is my time? So this is time. All right, I'm having you guys figure this out. If I drive 60 miles per hour, $40 miles per hour, 20 miles per hour. And do I go? Yeah, we'll go 10 miles per hour. All right, so you figure out what the time is here, right? You figure out what the time is. Press pause, take a second, try to figure it out before I continue. All right, so, well, I know my constant, right? My constant is what? It's the distance, 240 miles. I'm traveling that far every time, right? So my constant is 240 miles, and I know, right, that in x times y, I get my constant, okay? So if I'm traveling 80 miles per hour to go 240 miles per hour, well, 80 times what gets me 240, right? It's got to be 3, right? So 80 times 3 here gets me 240. If I'm traveling 60 miles per hour, 60 times what gets me 240? 4 hours. 40 times what gets me 240? 6 hours. 20 times what gets me 240? 12 hours. And 10 times what gets me 240? 24 hours. So we ask, is this a inverse variation relationship, right? Well, as one variable decreases, the other variable increases, and each time I multiply the input by the output, I get a constant of 240. So yes, this is inverse variation. Let's take a look at the graph. All right. So we'll graph it to the side here real quick. So let's go. I'm going to go to the next page. Do it on the next page. All right. So I know that this is my y-axis, x-axis, and I know my input is my speed, miles per hour, and my output is my time in hours. All right. So first, we'll go back. If I'm driving 80 miles per hour, it takes me 3 hours. So we'll say, should we go by 10, 20, 30, 40, 50, 60, 70, 80. All right, so 80 miles per hour, and we'll go by twos, I guess. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 80 miles per hour takes me 3 hours. All right, so that will be right about there. All right, 60 miles per hour took me 4 hours. Okay, so that would be here. 40 miles per hour took me 6 hours. So here. 20 miles per hour took me 12 hours. And 10 miles per hour took me 24 hours. All right, so if we were to graph this, all right, it's gonna go something like that, all right? So is this a linear graph? No, non-linear. And every time I multiply x by y, I get k, and it's non-linear. So this is a characteristic of a lot of inverse relationship graphs. As one variable is increasing, the other is decreasing, okay? So that'll do it for lesson 99, inverse variation.